All right, welcome. In this podcast, I'm going to be going over the problems from page 141, as you can see right here that we did in class, or I guess that I assigned last Friday. So I'm just going to start here on the first one that you did, which was number 37. Which is right here. You were already given the solutions to these before we started, or the solutions were in the back of the book since they were the odds. So you've got 8m plus 7 equals 5m plus 16. I have that here up on the screen, and I'm going to solve this fairly basic equation here. We need to get all of our terms on the correct side. And like I said, in general, I like to keep the variable terms, in this case 8m and 5m. I like to keep the m term positive. So in this case, I'm going to subtract 5m from both sides, minus 5m. And then the other thing that I need to do is I need to get my constants to the same side. So in this case, I have to subtract 7. That cancels out here. Subtract 7. That cancels out here. I forgot to cancel out this one here. And so what I am left with then, I will put in green, is now 8m minus 5m is 3m equals 16 minus 7 equals 9. And I just do some basic division there. Divide by 3, so m equals 3. And you can see that that was the solution to that one there. On the next one here, I have 21 plus 3j equals 9 minus 3j. And you can see as we start off here that the answer is minus 2. So let's see how we get to that. Again, we're going to follow the same process that we did before. We're going to work with these j terms. And so in this case, I have a minus 3j here. So I'm actually, if I move this, it's going to be positive. So then when it comes over here, I'm going to add 3j. That cancels out here. Plus 3j. Try that again. 3j. And so then I want to move my constants. And so in this case, minus 21. That cancels out here. Minus 21 over here. So here's where we got to be careful, because right here, this is a, going blue here, positive 9 and a minus 21. So we know that the answer down on the next level here will be, let me put the equal sign because I'm just going to bring that down, is going to be negative, since the absolute value of 21 is greater than, negative 21 is greater than that of 9. And then that will be 12. Okay, so I put minus 12. And then 3 and 3 is 6. So I have 6j here. Again, simple division. 6 by 6 cancels out by 6. And j equals negative 2. As we can see, that was the answer that we had before. Moving on to the next problem here. I have 6r minus 7 over 10. Equals r divided by 4. Now this was one that some of you were having a little bit of trouble with when we began the other day, and so I made the point that whenever we have a non-variable term in the bottom and it's just by itself, we want to try and get rid of it. So we want to clear out this denominator. So to do that, the first thing that we're going to do this problem is multiply by 10. So that's going to cancel out this 10 over here, but since we did that, we've got to do the same thing. So when I take this problem to the second level, what I end up with is a 6r minus 7 equals 10 over 4 times r, or 10r over 4. I'm just going to put the r separate to make this a little bit easier. Now, can we reduce this? Yes, we can. All right, so let's simplify this then a little bit. So we have now on our next level, we're going to have 6r minus 7 equals, and that reduces to 5 over 2r. Okay? And so on this particular case, what I'm going to do now is I need to get all of my variable terms together. So this 6r needs to come over to the other side, so I'm going to subtract this 6r, and then I'm going to subtract 6r over here. Okay, so what I'm left with is minus 7 on this side, and then I got to do the math for this here. So I'm going to come over here in yellow and just do the basic fraction math. So I've got 5 over 2 r equals minus 6 over 1 r. And I want to really keep track of my negatives and positives here. So where they meet up, so this is just still going to stay 5 over 2 r. and then this would be 2, and this would be minus 12. So again, I want to keep track of my negatives and positives. Here's a minus 12, and here's a positive 5. So that means that's going to be negative 7 over 2r is what that's going to equal. And remember, I had negative 7 over here equals negative 7. So if I have a fraction times a variable, there's only one thing I do, and that is multiply by the reciprocal. In this case, I'll just say negative 2 over 7. Okay, and then cancel, 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 cancel. And then I come over here and I'm going to put a little divider line over here. Negative 2 over 7 there, and then my 7 is going, because this is going to be 7 over 1. 7s are going to cancel out, and so that would be a negative times a negative is going to be a positive, in which case it will be 2 equals r. And you can see that that is our final correct solution. So if that gave you any trouble, just back up this video and watch me as I go through the steps of solving it. But what I did to begin with, and I'm just going to kind of highlight them in kind of this bluish color here. The first thing that I did is I multiplied by 10 to get the denominator out of there. All right, so then that gave me, I multiplied the 10 over here, so that's 10r, or 10 over 4r. And then I still had 6 over 6r minus 1, or minus 7 left over there. And then I reduced this 10 over 4 to 5 over 2. And then I subtracted this 6 right here. This 10 over 4 and this 5 over 2, the exact same thing, just to be sure. And then I subtracted minus 6 from 5 over 2. Okay, 5 over 2 is just a number. You could treat it as 2.5. So you could say 2.5 minus 6, but it's just 5 over 2. I want to keep it in fraction form so that when we get over here, it's easier to solve. Because if I changed it, if I made it as 2.5, it wouldn't be as simple to solve. So what I ended up with then is I got equivalent fractions, because you can only add and subtract like denominators. So we found the common denominator over here between 5 over 2 and minus 6 over 1. We ended up with minus, and we ended up with 2 equals r. Okay, so moving on to number 43. This one is, again, another one that's slightly more involved than the previous one. So we're going to end up with minus 8. All right, so how do we get there? Well, the first thing that we're going to do is we're going to take care of every single thing on this side first. All right, so since we have a minus 2 times the difference of b and 3, we're going to multiply 2, negative 2 times b. That's not a 6, that's a b. And then we're going to multiply negative 2 times negative 3. So negative 2 times b is minus 2b. Negative 2 times minus 3 is going to be a positive 6 plus 6 minus 4 equals 18. Now it's tempting at this point to do the 6, do the 4, negative 4, and then do the 6. But really all we need to do, let's combine these first. Okay. So I've got a positive 6 and a minus 4. That's going to give me a positive 2. So I'm going to say plus 2. I got minus 2b plus 2 equals 18. Now I can subtract this 2. Cancel that out. Minus 2 minus 2b equals 16. I do my basic division. Divide by minus 2. Divide by minus 2. And b equals minus 8, which is what you were supposed to get in the first place. So our last problem that we had to do was a consecutive integers problem. And so we talked about these the other day in class. And so we just need to figure out what is this consecutive integers problem going to ask us. And the consecutive integers all follow a pretty simple pattern. We just need to figure out where it's getting to. So it says find the sum of 3 consecutive integers. So that means that we're going to have integer 1 would be n, integer 2 would be n plus 1. So there's integer 1, there's integer 2, and then integer 3 would be n plus 2. Okay, so there's integer 3. And it says is equal to the sum of the first 2 integers. So this would be the sum of the first 2 integers, which would be 2n. So I'm going to put over here, I'm going to put equals 2n n, if the sum of the first two integers is equal to 24 less than 4 times the third. So 24 less than, that means minus 24, 4 times the third. So then that means 4 times n minus, oops, or plus, I can get that written, 2. That's a little janky there, but I'll rewrite this. How am I getting at this? First off, any consecutive integer problem, the first integer is 1, the second integer is n plus 1, and the third integer is n plus 2. So what it's asking us in this problem is find the sum of the consecutive odd integers. If the sum of the first two integers, so that means the first two integers, oops, I actually screwed this up. The first two integers would be n and n plus 1. So I got to add in the plus 1 there. So n plus n is 2n plus 1. So I got here and here equal this plus the 1. That's the sum of the first two integers. First two integers right there. Okay, it's getting a little messy here. And then it says is, which means an equal sign. Doesn't matter if I have it on the left or the right. 24 less than, so that means a minus 24, so I put minus 24. 4 times the third integer. So if I rewrite this, 4 times the third integer, which is n plus 2, and then 24 less than that, is equal to 2 times the first two integers is equal to the sum of the first two integers, which is 2n plus 1. So what I have here then, if I distribute this, I have 4n plus 8 minus 24 equals 2n plus 1. Switch colors here. And so if I combine these two right here, positive 8 and a minus 24, I'm going to get a minus 16. I still have that 4n right there equals 2n plus 1. I'm going to end up here and add this 16 plus 16, and that cancels out, plus 16. That gives me there. And then here I have 2n, so I have a minus 2n, cancels out, minus 2n. And so I end up with, that's not going to give me a very nice one, 2n equals 17. And so if I do divide that, then that is going to give me 8.5 divided by 2. And I don't think that that's the answer. N equals 8.5. So let's see what that gives us. And that is not going to give us 21. So somewhere along the line, there was a mistake. So I can see that in my work. So that's when I want to go back here. And let's start from the top and see if we can figure out where we made the mistake. All right. So I'm going to start going backwards on this a little bit. And let's see where the mistake falls. Okay. So let's make sure to start off with that we have the correct problem. And again, it says the sum of 3, oh, that's where the problem was. It was 3 consecutive odd integers. I did consecutive integers. So what we need to do is clear the page from the beginning. I just showed you how to solve the problem if you were using consecutive integers, but the problem asks for consecutive odd integers. So we want to reestablish that. So our first integer is going to be n. The second integer will be n plus 2. So if it was 1, then the next integer would be 3, and then the third integer would be n plus 4. There's where our mistake was, is if you do consecutive integers, you're not going to get the correct answer. So you need to do consecutive odd integers. So let's reestablish what the problem is. If the sum of the first two integers, so our first two integers are n and n plus 2, the sum of that would be 2n plus 2. And that is going to be equal to 24 less than, so minus 24, 4 times the third integer. So 4 times n plus 4. Nice and simple there. So now when we resolve this, we're going to get a nice clean answer that will be 21. So first thing I need to do is distribute here and here. So that's going to give me 4n plus 16 minus 24. Still is going to equal, this hasn't changed over here yet, 2n plus 2. I combine my 16 and my 24, and this time I have minus 8. I have 4n. I still over here have 2n plus 2. I'm going to switch colors here. And then we're going to add the 8 right here, plus 8. And then over here, I'm going to subtract this 2n. That cancels, minus 2n. This is going to be 10, and this is going to be 2n divided by 2, n equals 5. But we're not done yet, because what it is asking us is what is the sum of 3 consecutive odd integers. So now that we have 5, we can put the 5 in here. 5 plus 2, 5 plus 4. So this is 7. So I'm going to put that over here. 7. This is 9. And this is 5. 9 plus 7 is 16 plus 5 equals 21, which is the answer that we are supposed to get. So there you have it. It's easy to make the mistake on this problem if you just do a consecutive integer problem as opposed to a consecutive odd integers problem. And I made that mistake a little bit on purpose so that you would see that. So please be careful when you are doing this. It's really easy to make that mistake. So that's all for today. Your assignment, the rest of your assignments will be on the computer on that quiz.